Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the general relations for dS. The state postulate established that the state of a simple compressible system is completely specified by two independent intensive properties. Therefore, we should be able to calculate all the properties of a system, such as internal energy, enthalpy, and entropy, at any state once two independent intensive properties are available. This is certainly good news for properties that cannot be measured directly, such as internal energy, enthalpy, and entropy. The calculation of these properties from measurable ones depends on the availability of simple and accurate relations between the two groups. From this task, we will develop general relations for changes in internal energy, enthalpy, and entropy in terms of pressure, specific volume, temperature, and specific heats alone. We also develop some general relations involving specific heats. The relations developed will enable us to determine the changes in these properties. The property values and specified states can be determined only after the selection of a reference state, the choice of which is quite arbitrary. Now, let's try to find the general relations of specific entropy. With natural variables of T and V, the exact differential of entropy is one of the conjugate variables can be substituted with the third Maxwell relation. The other of the conjugate variables can be derived with the definition of constant volume specific heat. The exact differential of entropy then can be simplified as: this is the first equation of dS. When the entropy depends on natural variables of T and P, the exact differential of entropy can be simplified as: this is the second equation of dS. Similarly, when the entropy depends on natural variables of V and P, the exact differential of entropy can be simplified as: this is the third equation of dS. Either relation can be used to determine the entropy change. The proper choice depends on the available data. Discussions. 1. 3 dS equations are available for any working fluid. Taking an ideal gas as an example, the equation of state can be expressed as: the first dS equation for an ideal gas can be simplified as, which had been derived in Project 4 based on the first law and the definition of entropy. The second dS equation for an ideal gas can be simplified as. The third ds equation for an ideal gas can be simplified as. 2. It's easy to measure Cp, so the second ds equation is extensively used. Okay, that's all for this task. Thank you very much, and see you next time.